Okay, let's start our next session is on tutorial part 1. So in this tutorial, we are going to do some calculation based on how to calculate the electronic energy level, some conductivity studies. Before do this question, I will go through some important the formula and the method to be used to solve this question. And I will give you display the question here, and you try by yourself and let me know. I will find out if there is any problem. I'll let you know. I'll check the answer from you. If you have any questions, you can ask me. I will come and explain to you. And as I said in the previous lecture, I showed this slide, how to calculate absorption. Okay. So if you ask the question, some of the spectra, I will give you absorption spectra. From the spectra, you need to find out what is an onset absorption. Then from that, you can find band gap. Suppose if the band gap is given, so what should be the absorption? This is a very simple question, but when you do the question, you will have more understanding. So how this absorption play role and how to. So tomorrow again, I'm going to see that we are going to do the hands-on experience how to collect this spectra. So we have the UV spectrometer and we have some samples and let you do that. So now we do the questions. So tomorrow you will have. So that will give you some taste of working in this how to characterize the material in a highly professional way. So that's what I'm going to say. Okay. So many people you can say there's some lovely spectra. So if you have the things, if you are not getting good spectra, what's the problem? How to correct it? How we get a good spectra? And what's the difference between the, just know by seeing the graph, you know how the solution spectra and film spectra looks like. What does it mean? That's main important. Why now you should have the question why absorption spectra of film is different from solution. The definitely question is, the answer should be the structural arrangement, the crystallinity. Solution, the arrangement, because crystallinity will change the structure. Even though if you talk about the basic one, if you are drinking water, if you cool down the water will become crystalline. It's a regular ice form. So property entirely different. Okay. So any material is because what state the property will be different. That's why we are going to see the absorption spectra is different. Okay. So you know that I already explained to you. This is a basic energy of h nu. From this one, you no need to remember. Just remember this formula: 1240 eV divided by lambda. So whatever the wavelength onset, you should convert it into nanometer level because this is nanometer, and you will get eV. If you want to give the energy level, then you need to multiply by what is that energy level. So eV, whatever eV, then you will get a joule per meter. Okay, this one, and next one is CV. In the CV spectra, I will give few published one, reported one, people already calculated one. The CV spectra. From the CV spectra, you need to find out the onset, and remember this formula you can write down, minus 4.8. Using this formula, you have to find out what is HOMO and LUMO, and even this HOMO LUMO also will give the band gap. Sometimes this band gap will be different from what you calculate from the solid state band gap absorption. So because obviously that will be different because both method is different. You will give a difference, and some type of explanation will give. Okay. So note down. The question is based on this one as well, and next thing is I'll give some question on base. We are going to discuss about more on ultraviolet photoelectron spectroscopy. This is another method to find out what is Fermi level, what is HOMO and LUMO level. So this is more accurate method, but these are all processes on high vacuum technology. We have ultra high vacuum. Then we have basically this technique is based on photoelectron effect. I think everyone knows about what is photoelectron. We incident photoelectron, then emit electron will be emitted. Here we use a X-ray photon and emit electron out. Here X-ray is comparing to visible light, UV is higher energy, and comparing UV, X-ray is higher energy. When you have a higher energy X-ray photon, it will eject the core electron, this K cell. K cell is a higher inner cell. The inner cell electron will eject out. So we have a complete information about what is the chemical nature, what is the chemical, all the chemical information we get in X-ray. But if we have say UV photon, then we have only the valence band. What is a valence band? Then valence band electron will come out. Okay. So it depends on what energy we use. According to that, the energy will come out. So what is showing that is, we know what is the input energy given. Normally the formula is same. What in En equal to E out. Whatever giving energy, it will come out. Okay. But the input energy will be used for something else, because input energy will use for to eject the electron. So the same input energy will transfer to energy at the same time. This electron have some type of binding energy. So if you put energy is more than binding energy, then the electron will come out, right? If it less than binding energy, it doesn't come out. So whatever the input energy will be useful to liberate this kinetic energy plus kinetic energy of this electron as well as the binding energy. The input is equal to kinetic energy and the binding energy. So this spectra will give in terms of what is binding energy and how much electron come out. So binding energy is nothing but h2 by Ka. So this spectra is plotted against binding energy versus number of electrons come out. So you can see that the input in UPS spectra, the input energy is 21.22 eV. Okay, this is fixed one. Because normally the UPS spectra will take about helium 1 photon is energy source. It will have a 21.22 eV volt. So the HOMO level is connected using this formula. Okay, H nu is the input, that is 21.22. E cutoff. E cutoff is a secondary electron cutoff. Secondary electron cutoff, if you see this energy, that before this everything is zero. What does it mean? Kinetic energy means whatever the kinetic energy is, whatever the input energy and kinetic, both are equal. If it is both are equal, then it will become zero. That means the whatever input energy, it doesn't do anything, it just reflect out. Okay, it is not doing anything else. By increasing this energy, at some point it can show some of the emission. It shows that something electron is coming out at this energy. So this energy is called like Fermi energy, because when you have this electron, this is a valence band, top is a conduction band, LUMO. In between the Fermi energy will be there, the Fermi level will be there, Fermi level. So this cutoff electron will shows that what is the Fermi level. After that, it will shows again at the end point, it will shows here around 0. This point will show that what is the HOMO level of this one. So you have to input, you cut off this energy and plus what is the onset of this one. Like this, if you show this spectra, here at -1, this is kind of Fermi level energy, and finally at 0 level nearby, at this level, we have another onset we can say. From this one, we can calculate 1.04. That one will be the E onset. So only the h nu by E cutoff is Fermi energy. Fermi energy plus E onset is your HOMO. For example, if you see here, in this one, Fermi energy is somewhere here. Okay. In addition to that, plus this part is HOMO level. Again, Fermi energy is somewhere in the middle. You can assume that from middle to the HOMO level point extra, no, that will come. That will show here actually in this onset. So Fermi level plus HOMO onset will give the total HOMO of energy level. Hope you understand this point. Okay. So you remember this equation. E cutoff is the electron and HOMO level onset is E HOMO equal to this formula. So this is the basic things. I will go in detail tomorrow in lecture about this one. This is one of the how to characterize these things. But tutorial purpose, you need to know this one. So now I will display the questions and you can go ahead and do that. Yeah, number 1, 2. Yeah, you can go through these two questions first. So it's both a simple question. Calculate the band gap of polymer semiconductor in onset longer. I think I give the answer for the first question. Anyway, it's for question, but you can do the how to calculate this one. I think I already gave the answer for first question. So you go to the second one. So this answer, I put it here. You need to take appropriate answer. You can find out. Here you can imagine roughly you can take and do that. And no need to have any exact one. You can roughly take out define. You can't see that? Okay, I will put. Okay. You can see, right? No. If you are done, just let me know. I'll go to next question. So you can roughly define. We need to draw the tangent. You roughly define and do the things. So it's a very direct question. It's done or not? No. Two 40. First answer. First. Yeah, you should find solid state. Where to speak? I put two, that's why confusion. You need to still write one. You only take two one. The first one that you're asking, the first one. Where is two? Which one? Yeah, it should be. Yeah, you should say thin film. Yeah. Yeah. 2.2. Yeah, according. A little bit of, yeah, it's okay. 1.25 maximum. Is it 9, 10? Nine, 10? No, if you draw the tangent, it should be around 9:20 or 9:30, right? Good. Any question? It's okay, it's easy, right? Okay. Just roughly define what is it. Just to make a feeling of, we can also do how things, because you may not be done in you are doing MS system. Physics, right? No, you are master's or PhD? Research scholar. Okay. It should be known, okay, it should be easy. You're done, all are done. What's the answer? No, I said you should not take solution, it should be filled. You want to do other one. You can't able to do the next one, next graph. Okay. This one only, this solution. This okay, because the band gap usually calculate from a solid state IG. Okay. So for solution? No. I put two things, but you should calculate from the, you got to take only film, because these are all same material. Same material. Yeah, same material, only solution film. You got to take film. Film only? Yeah, I told you right in the lecture. The band cap should be in the film. Okay. Not in solution. Yeah, that's right. So this is not 950, it's around 920. Huh? We will take tangents. If you see this, the absorption tangents answer. Yeah, not that's why it's really is an onset. I said onset normally exactly for the bottom tangent and so on, but at least we need to have the straight line tangent. Like other I show you, right? The one I put it, so the left one. I saw the line, right? Like this. Yeah. Longer wavelength peak. Yeah. Hey guys, okay? Any problem? It is okay. 1.7. What's the wavelength peak? 2.3. This one. 520. Is it 520? No, it's a lot of come around 600, right? You didn't see that? If you draw the tan, is a red curve, right? You're talking about. It's almost 600. It's not 520. Is it? Can you see that? Yeah, this part if you take the tangent, where is it coming? 620, right? So the tangent I show that here, the line, the left hand peak, right? You don't take the peak, it's onset. I think we're considering peak, right? Don't take peak, onset. That's why I saw the left hand side, how to draw the line, onset. So your back side, you are not doing anything. Yeah? Insufficient papers, yes. Hey, no, we got paper. I'll just, no, it's okay, I'll give. You would ask them. Just to at least learn something, that's why we conduct this type of tutorial. Okay. If you run out of paper, come and take me, okay, this one, I'll put it there. One paper. Are you okay? Any issues? Okay. I think it's okay. I think it's very easy one. I'll go to the next one. I think most of them I checked, it's okay. It's whoever knows the multiplication division, I can easily do that by already give the correct formula. So this also same thing. I a little bit changed. This LUMO level of the PCBM acceptor is given. You don't need to already give the onset here, reduction potential of this one, minus 15. And if the band gap is 1.9, what is the HOMO level? Because these all are reduction potential. Reduction potential will give you the LUMO level. You have to remember the formula. That means minus 4.8 and minus reduction. Then you got to use, right? Then that gives the LUMO. So, huh? Assume it, yeah. I already given the reduction in the bracket. You use that value. Already given the value here. The reduction potential value is given here. You just use that value, use the formula, find LUMO, and then I ask one more question. If the band gap is 1.9, what should be your HOMO level? You know what is the connection between the band gap, HOMO, LUMO, you know, right? Yeah. At least that's the only you need to understand now. That's what you see this plus minus minus, right? What is plus minus? Plus into minus should be minus, right? How come it will add up? It will be subtract, right?
Minus into minus.
No, don't. Minus is okay. You take always everything's minus. I put everything bracket. You go to do bracket first. Then that's why I specifically put in the bracket. So that the hierarchy is you finish the first. You keep the minus outside. First to do the bracket, then you do minus. Okay. And also you see the LUMO level mean this is from this point it should be below. HOMO is up. Okay. That's why I explained to you. Remember? If this is a reference point, LUMO is somewhat below, HOMO is up. But now is up. So you have to take careful, okay? How come this is 3.65? Yeah, correct. Minus 1. Okay, call it on. I want to find out this is the band, right? This is one. This is HOMO, LUMO, this is top. This is LUMO, this is band.
Yes, sir.
So if this is 3.65, if you add all this one, you get this. Yes. So what is HOMO? No. This is the energy level. If this is HOMO, if this is LUMO, and from between HOMO and LUMO, this is EG. From this one, you just plus this one. If you add band gap, then you got this one. HOMO. That's why I give the what is band gap. Band gap. No, this should be, you don't do that. The minus keep like this. Add up, take it minus. So it is up, this should be increase, okay. This one, what is 5.5? Yeah, right. 1. Yeah, just be right minus. There should be 4, right? Okay. No, this side. This you find LUMO. So if you say this is LUMO and HOMO, this is band gap. If this is 3.65, you add this 1.9. If you add this one, you keep minus because this below the reference. If you add this one, it should be 5.55 something. But minus. You go to this. I put everything in bracket. You go to do the bracket first. Don't do it. Should be up. Yeah. No, no, this is HOMO. Bottom is HOMO. So this energy should be lower than. You got to understand the concept first. That's why I put this one bracket. Got it? Okay. okay? Yeah, that's right, okay. Yeah, right. So many people, they take minus inside, they don't. So when you have the HOMO-LUMO, don't take out the minus, keep always, because energy level is always in the negative. Don't take it minus inside. Just to do the bracket, just simple thing. Just is, you go minus 4.8, if you, reduction is minus 4. Then from that value, just add your band gap, you'll get a HOMO. LUMO is always top, HOMO is in below, okay? Yeah. Yes.
Previous problem is you have given a molecular structure. These UV absorption spectra, is it for the monomer or for polymer?
I give the name only, I give the structure as well. Whatever.
You had given a structure.
Yeah. That's a small molecule. This is small molecule one.
Small molecule. Spectrum is for the small molecule. Reduction potential from the
That's why I say that. If you see that the first answer, you see
first answer is
this one.
okay. Oh, intersecting point.
You can see that roughly. You can see like this. The first one, reduction. In this case, they all negative one. The oxidation is still further, not here. This one I can't take it oxidation one. No, that only can't take it out for in this case. Yeah, because yeah. No, see, but oxidation we need to take at least the positive side generally. Yeah, because there is many oxidation reductions. If you further when you have the HOMO level, we need to have the plus side oxidation. There is many reduction state will be there, but still when you have this now 2 peak is coming, 2 reduction, 2 electron reduction, then LUMO is, you are calculating the HOMO means highest to the highest occupied molecular electron level. Here we can't consider a band gap. Here only what is the reduction means first onset only take reduction potential when you have negative peak. We have the oxidation case. In oxidation. In oxidation is first. Yeah. Plus side coming first one, yes. No, I said oxidation directly. I said we can directly, but these are all completely acceptor level. It will oxidize easily. So we can't get oxidation for band gap purpose. We can't say that. We can't take it away here. We need to understand what's happening here. Here is a 2 electron band gap. When you do oxidation cycle, you go first electron. But actually, if you have HOMO level, that's the highest occupied molecular level. So when you have LUMO level unoccupied, then there a lot of level comes. It won't come immediately. You go to cross the positive line. From that point, you will get oxidation. That only you take. Okay. But this one, most of the acceptor we can't do like this. Okay. So we consider only, that's why when you calculate HOMO, you only LUMO level, I take it from for acceptor only LUMO level, take it from this one. HOMO level will calculate from the band gap. Give band gap. Okay. Otherwise, it's because if you take this one oxidation, it doesn't make sense. Immediately, it's very low. It's not. Yeah.
subtract this or add this. Actually, we are getting the LUMO for minus value.
Add.
You have to plus 1.9 means we will be getting minus 1.17.
No, add. We minus common only because everything you put in the bracket if you see the formula. Do the bracket first. Do the bracket first. Yeah, if you do the bracket first, then what will come?
Actually, this is, we can't put this. This 3.6 is the 625 average of full LUMOS plus 1.9. If you take the minus outside,
Both of them
3.65 minus 1.9.
No, the formula itself is K minus 3, which one?
3.625.
Yeah, and plus whatever. This will be inside. You add this one first, then take a minus out.
How can you pick the minus outside?
Minus keep outside, don't mention, whatever the early. This is not a direct mathematics. You should understand how the HOMO level works.
Actually, the LUMO should be lowest or highest.
High. The energy level, with the vacuum level. I said that if you see there is a vacuum level. Okay. So this is your Fermi level EF. So LUMO is here means HOMO, it should be down, highest occupied. Then if you have a 3.9, this should be around 5. So you should have increase. You should have some understanding. That's why I initially tell that how the HOMO LUMO. We can't put directly in this way. You got to understand where the HOMO and LUMO. So HOMO should be below the LUMO. Okay, don't take mathematics directly. You go to that's why understanding.
Actually, HOMO should be lowest.
Valence band, conduction band, HOMO.
If it's 5.5 level,
This is energy level high.
இது கீழே எல்லாமே minus தான். Whatever the below is.
ஓகேவா minus 3.6 அப்படினா அதிகம்.
அப்போனா அப்புறம் லூமோல இருந்து மைனஸ் பண்ணனும்.
இல்ல plus 1.9 ஆட் பண்ணனும். அதான் சொல்றது. புரியுதா? மேத்தமேட்டிக்ஸ் புரியுதா?
Value is right.
Take reduction potential. The potential where the reduction current is there. Is it how you
This is onset. So now if we say that UI is coming right.
Yes. The potential at where?
This and this point.
Okay.
Where this tangent and this tangent meet.
Oh, okay.
Like how you did the onset of the absorption, the tangent. Okay, you know right?
Another reduction is there. We don't
But
consider
we take a consider first one. That's already oxidation. The reduction is starting, right? Because in PCBM there is many electron. There is a first electron reducing. So this is the lowest unoccupied. Lowest means what is the minimum it reducting. That's why we take the first one. We don't need. In further there will be a lot of vacancy level will be there. We need to consider only the first one. Okay, got it. Question? Yes. That's right. It's correct. Yeah. You don't understand like HOMO, you bring the vacuum level first LUMO, then HOMO. So you don't need to take direct mathematics, you just take, because someone is making plus minus. So this is right. Okay. Good. I think most of them got right. And I'll go to the next one. You have a problem? Yeah, this is right. So I'll go to the next one. This also is same thing, but here I point out how to, last time we have the question, how to find the answer. Here I put how to find the answer. right? I draw the tangent and put the onset. The right hand side is the oxidation potential, left side is the reduction potential. Now you find out what is HOMO, LUMO, and band gap. Correct? I asked 3 questions. Yeah. That you got to, positive side is oxidation, negative side is reduction potential. So you got to use the formula minus 4.8, okay? So I give the different graph, so how do you can, that will give the more idea how to calculate this one, okay? I think it's visible, right? What? Yeah, minus 4.8, yeah. Plus the same thing, minus 4.8 plus oxidation minus, and huh? So don't worry about those things, you use the formula. Yeah, right. 1.5, 0.5. 4. You okay? Sorry?
This belongs to engineering, not in the field of chemistry.
Yeah, but this was simple calculation.
Simple only, sir.
Yeah, okay.
And this
Okay, you write the formula first, minus 4.8 plus. Yeah, right, this one. 0.6, right?
For this one,
Yeah.
yeah.
You are calculating LUMO, right? Minus, yeah. Yes, sir. Yeah. Homo 6 point, okay.
Minus 4.8 plus ER. Yeah, so first one is 1.5.
No, what is value? Oh, 6 point, okay. Yeah, if you done this one, the rest of things should be okay. Two point four. Oh, band gap, okay. Yeah, right. Sorry. GIAN 2, yeah, right. It's okay. Any issues? You guys are okay. Reduction. Yeah. Yeah. Yeah, the same. It's a direct method.
Oh, that is oxidation potential energy level. Can we can reverse the signs, right? Is it
You
possible?
cannot just use sign, because if we have already sign is there, minus. If it is oxidation plus, reduction minus. Use that sign. Always here plus is there.
Okay.
If reduction is all become minus, it always become plus. You keep the minus outside out.
Okay.
Plus. Yeah, just put the value. Already is plus minus is there. Yeah, yeah, right. Good. So you need a note paper. Paper. Point 3, 6. Okay, 2.2, right. One paper. 3, 4. Okay, you're right. Same thing, right? Good. It's okay. Okay. There's one paper. I think most of them got right. Anyone? Okay, I will go to the next question. 5. This question regarding UPS spectra. I given the spectra and also given the onset already given. Just to find out, calculate the Fermi level and HOMO level, and if the band gap was about 2 eV, calculate the LUMO level. The same thing, but the spectra is different. So here you go to 3 things. Fermi level, what is Fermi level? That is minus secondary electron, and you got to find out HOMO LUMO. But this is from UPS spectra. Did you write down the formula which I gave the previous slides? Then if you write down the formula, then you can easily find out. Because when he teaches, you just remember find the formula. When you really apply, then you come to know how to calculate. You try that using this is a direct method. Yeah, the cutoff is secondary electron cutoff I already given. I already given what is the E cutoff is a secondary electron cutoff. Yeah, I give the HOMO onset. So I already given the formula here, h nu by cutoff. What is secondary electron cutoff? I give the formula also. And I ask the question, if it is band gap is 2, what is a LUMO? From this graph, you can find out what is Fermi level and what is HOMO level. You see the formula. You have to have some imagine how is that, where is a Fermi level, where is a HOMO level, where is a LUMO level. You need to have some idea. Yeah, onset is there. This is a HOMO onset. It just is a one more new term is a Fermi level is coming here, remaining things same. Yeah. Fermi level just calculate from the cutoff, secondary electron cutoff. What is a Fermi level? That is your input electron minus cutoff, it will give the Fermi level. Input is 21.2 minus your cutoff is Fermi level. Because when you have input, the Fermi level is a free electron, that's a 1 electron come out, right? The HOMO level is still deeper. It will have more energy to come out. Okay. Yeah, this is a cutoff, where is onset? What is h nu? Yeah, you have to put the value. Yeah, that's right. So this is your Fermi level. Just move. No, I use Fermi level and HOMO level. This is HOMO, right? The equation. This is right. If you want a Fermi, this is Fermi. Okay, got it? If anyone don't write down, the formula is there anyway. Then I give the formula, yes. You want? Any questions? But I asked 3 questions. Calculate the Fermi level. HOMO level is the formula is there, E HOMO equal to. And how to, if you know the HOMO and if I give the band gap, then you can find out what is a LUMO. Right? Just now I told you the previous question, right? If you know LUMO, if you LUMO plus band gap, you know what is HOMO. If you know HOMO, if you know and band gap, you can find is a LUMO, right? Plus just the addition only. But you know how to addition, because always remember your HOMO is top, the HOMO is below, okay? Then it will be below the number. So the Fermi level is nothing but your input kinetic and minus secondary electron cutoff is a Fermi level. So in that equation, just to forget about the HOMO, that's your Fermi level. Okay. Correct? Yeah. Anyway, at least you can start thinking of what is this type of value. You can always find it. Anyway, tomorrow I will go through detail, you will come to know, just to do the question. I already give the formula and everything. You can directly apply and find out. Oh, it's confusing. Okay. Think about it. Yes. Yeah, Fermi level is just 2. Catching my cutoff.
This is Fermi level.
Yeah, that's a Fermi. Yeah. If you had answered, then become HOMO. What is it? Yeah, that's Fermi level. In this one, add HOMO, you'll get the HOMO. Yeah, add the HOMO cutoff, you'll get a HOMO level. That's the formula I given, right? E HOMO equal to Fermi level plus HOMO cutoff is HOMO level. Yeah. Because Fermi level below add, then HOMO level come. Then if you add band gap, you'll get LUMO. Yes, any question? What's the doubt?
Secondary electrons
Yeah.
cut off.
That you can find out. I'll draw the line, right? In the graph. You can't see the line.
Cut off.
Yeah, that's cut off.
So onset values.
Your answer is right hand side.
Right hand side.
Yeah, that's wrong. So only this one is a Fermi level. If you add plus, I should plus, right? Not minus. Get bracket this plus. I wrote in the formula, right? First you find out this one. This is your Fermi level. Add HOMO. Plus. That's your HOMO. And if you know the band gap, then you know what is the LUMO level.
Okay.
E cutoff you can find out from the cutoff, second electron. First cutoff. First graph is cutoff, second graph is HOMO. Yeah. Fine. Yeah. Yeah, correct. This is HOMO level. Then this is only Fermi level. This just minus is second, this is a Fermi level. And HOMO. Then if you add band gap to HOMO level, you will get a LUMO level. Got it? Yeah. I have the band gap. You add the band gap, you will get LUMO. Right? You got it.
Should there be a minus here?
Yes, but you don't worry, only do the bracket first. Like, yeah.
21.22 minus 16. This is common level, this is plus onset, it gives a HOMO. But I don't get the minus if we do that.
No, it's okay. Suppose minus should be there outside, it is not there. Yeah. Finally, some minus should be come, but it's okay. Your version, well, yeah, okay. Yeah, initially, the whole value should be minus. It's not there. So, yeah, it's okay. Yeah. Yeah. So where is LUMO? We have said the band gap is 2. Band gap is 2, you follow. Minus, why you put plus? It's minus, right? The cutoff minus. No. First plot. That's a, yeah. That's why I said the secondary electron cutoff.
16.70.
Yeah. That is a HOMO onset. Yeah. Left. Right. You take the invert. This should be, this is first again. 6, 7. Remove upright. Huh?
This is 2 electron.
No, no, you remember, the HOMO here, LUMO is close to 0. Up should become.
Subtractive.
Yeah, subtractive.
But LUMO, always LUMO will be higher energy than HOMO. No, sir.
What in terms of you? In terms of
Generally,
mind.
when you see band gap,
Yeah. First LUMO, HOMO is deeper down.
so LUMO high energy is higher.
Energy high, but numerically is less. If it is right. Numerically less, suppose. If this is your vacuum level. Okay. First is LUMO. Then your HOMO. This is your band gap.
So this means
If this is 5.2, so this will be around 4. It's less. Numerically less. But in terms of wood minus, it's higher.
here I am getting positive. No, sir.
It's fine. I'm only done now. Don't worry about the plus negative. I want to see the what's the value you're getting.
So I have to
But
subtract here.
the formula itself should come minus, like other things. All formula is minus. Yeah. Okay.
Let me proceed with the next. See, here it is negative 5.72.
No, just a cutoff is okay. From cutoff 4.12. Where is your HOMO onset? 4.12 plus 1. Yeah, this is your HOMO. 5.72. Yeah, this LUMO. Yeah, correct.
H2 is 21.22. E cutoff is
Yeah, this is your Fermi. No, okay. Yeah, correct. What is this one? Then you got to add plus 4.4, right?
yeah, that is added.
Add it.
21.
21 minus 6.7, how much?
This is 4.52
Yeah, correct. For me.
plus
Yeah.
0.4 is added.
But if you do this one, 4.52 is your Fermi level. 4.52 is your Fermi level.
Oh, 4.52 is Fermi level.
Yeah. That's right. I asking the Fermi level as well. பேப்பர் இருக்கா பேப்பர் இருக்கா முடிச்சுக்கோங்க பேப்பர் இருக்கா இல்லை முடிஞ்சது இருக்கு. அது முடி when you see the formula is easy, but when you do the things, they have some confusion. So when you do practicing, they will okay. They'll be. Any problem? பூவா இல்லை நான் இப்போ கொடுத்துட்டேன் வந்தா So this is your Fermi level. What is this? Yeah, what is this? LUMO should be less. This should be subtract. You want? Yeah, LUMO top, HOMO, right?
HOMO is this one.
HOMO top, right? Vacuum level. If you have this 0, this is minus somewhat 3, this is minus 5. And numerically, this will be less. I said
HOMO should be less.
less in the sense that In what sense?
compared to LUMO.
No, do you understand the first point? At the maximum level, LUMO is unoccupied is up top, highly occupied state is down.
Okay, yeah.
That's higher, numerically higher, then LUMO should be top. So you will be some. So you got to remember, don't confuse the minus term because always this value is minus because everything we are dealing with the negative electron, so minus you keep it down. So
I got 4.97 HOMO.
so from your previous one, what is LUMO is lower or HOMO is lower in previous one?
HOMO is lower. HOMO is lower. We just added two to get
So what is LUMO is higher or HOMO is higher?
LUMO is higher.
In previous case, CV? LUMO is higher, right? LUMO is,
LUMO is higher, sir.
yeah, this is HOMO, this LUMO, right? Which is higher in this one? This is HOMO LUMO, which is higher?
Plus is oxidation. Oxidation is HOMO.
No, here minus is always there.
Okay.
Don't even let me move the minus.
Okay.
You got it?
Just give and you can please pass off.